Monday, August 10th, 2026. Somewhere in the middle of the country right now, a piece of cold air is quietly sliding south out of Canada, and by itself that would mean almost nothing. Cold air moves south every single week of the year. But this particular piece of cold air is about to run directly into a wall of Gulf moisture so thick and so unstable that when the two collide over the next several days, the atmosphere over a huge stretch of the central United States is going to load up with more raw energy than it has carried in weeks. And what happens when that energy finally releases is the part that has meteorologists watching this setup with real concern instead of routine interest. This is not a normal summer thunderstorm pattern. This is the kind of atmospheric setup that, historically, has produced some of the most destructive multi-day severe weather outbreaks on record. Let's walk through exactly what is coming together, why it is dangerous in more ways than one, and what the actual numbers say about who is most exposed. To understand why this setup is different from the pop-up thunderstorms that roll through almost every summer afternoon, you have to understand what ingredients a severe thunderstorm actually needs, because it is never just one thing. It is always a combination, and the more of these ingredients stack on top of each other at the same time, the more dangerous the outcome becomes. The first ingredient is moisture, and right now there's an enormous reservoir of it streaming north out of the Gulf, pushed by a low-level jet that is drawing tropical-grade humidity hundreds of miles inland. The second ingredient is instability, which is essentially a measure of how much energy is available for air to rise explosively once it starts moving upward. And forecasters measure this using a metric called CAPE, convective available potential energy. When CAPE values climb into the 2,000 to 4,000 joule per kilogram range, that is the kind of number associated with the most violent thunderstorm updrafts this country sees. The third ingredient is wind shear, meaning the wind at the surface blowing one direction, while the wind higher up in the atmosphere blows a different direction, or faster in the same direction. Shear is what takes an ordinary thunderstorm and organizes it, tilts its updraft, and in the most extreme cases gives it the rotating internal structure that becomes a supercell. And the fourth ingredient is a trigger, some kind of lifting mechanism, usually a front or a dryline, that actually forces air upward and gets the whole process started in the first place. What makes this week's setup worth taking seriously is that all four of those ingredients are lining up essentially at once across the same corridor. The cold front pushing down from the north is providing the lift. A dryline, that sharp boundary between moist Gulf air to the east and drier desert air to the west, is sagging into the southern and central plains and will likely become the focal point for the most intense storm initiation. Above all of that, a disturbance riding through the upper atmosphere is going to sharpen the wind shear right over the same area where the moisture and instability are already stacking up. When forecasters see a dry line, a surface front, strong instability, and increasing shear all converge on the same days over the same geography, that is precisely the recipe that has produced some of the most talked about severe weather outbreaks in modern American history. And it is exactly why this setup has moved from a routine mention in a forecast discussion to something meteorologists are actively flagging days in advance. It helps to actually understand what is happening inside one of these storms once it gets going, because the process is far more mechanical and far more predictable than most people assume, even though the outcome can look almost supernatural from the ground. Once a storm's updraft becomes strong enough and the surrounding wind shear is organized enough, that updraft doesn't just rise straight up, it begins to rotate, tilted and stretched by the changing wind direction with height until the entire lower portion of the storm is spinning around a vertical axis several miles wide. Meteorologists call this rotating column a mesocyclone, and it is the defining feature of a supercell, the single most dangerous type of thunderstorm this country produces. Not every mesocyclone produces a tornado, and predicting exactly which ones will is still one of the hardest problems in operational meteorology. But when conditions align, that broad rotation tightens and accelerates near the ground the same way a figure skater spins faster by pulling their arms in. And what began as a slow, wide rotation several miles across can concentrate down into a violently spinning column just a few hundred yards wide within a matter of minutes. That is the moment a wall cloud can drop a funnel, and that funnel can reach the ground as a tornado. The entire sequence, from a visible rotating wall cloud to a tornado on the ground, can take less than 10 minutes, which is exactly why waiting to see a tornado with your own eyes before taking a warning seriously is such a dangerous habit, especially after dark when you will not see it at all until it is far too close. This year's broader pattern matters too, because it is not business as usual. Coming into this severe weather season, La Niña was still lingering, and La Niña tends to suppress the kind of classic high-end tornado setups the plains are famous for. But La Niña has been fading fast, and as it fades, the atmosphere becomes more supportive of exactly the kind of large-scale instability and organized storm systems that produce not just isolated tornadoes, but widespread multi-hazard outbreaks. Forecasters have been saying since the spring that even in a year with a lower overall tornado count, the individual events that do occur could carry outsized destructive potential, because the atmosphere is behaving less like a tornado factory and more like a broad, severe weather engine capable of producing giant hail, destructive straight-line winds, and flash flooding on a scale that spreads the danger out across a much wider area than tornadoes alone ever would. Let's talk about the specific hazards, because severe weather is really an umbrella term covering several very different and independently dangerous phenomena, and this week's setup has legitimate potential for all of them at once. Start with hail. When the same intense updrafts that produce tornadoes and damaging winds are instead capped by a layer that suspends developing hailstones in the coldest part of the storm for longer, those stones keep circulating and accreting layer after layer of ice until they are large enough to fall out. Large hail, meaning anywhere from golf ball to baseball, sized and occasionally larger, is capable of destroying roofs, shattering windshields, killing livestock caught in open fields, and, in the most extreme documented cases, causing direct human fatalities. The corridor most consistently flagged for the highest hail risk this season stretches from Texas up through Oklahoma and into the mid-Mississippi Valley, with the secondary hotspot across Iowa, northern Missouri, eastern Nebraska, and northeastern Kansas. And this week's setup sits almost directly on top of that corridor. The physical process behind the largest hailstones is worth understanding because it explains why some storms produce pea-sized hail and others produce stones the size of grapefruit. Inside a strong updraft, a small ice pellet gets carried upward through layers of supercooled water droplets, picking up a new layer of ice each time it passes through, then gets suspended near the top of the storm where temperatures are far below freezing, then falls, then sometimes gets caught by a fresh surge of the updraft and carried back up again for another pass. The strongest, most persistent updrafts, the same ones capable of supporting a rotating mesocyclone, are also the ones capable of holding a growing hailstone aloft, long enough to build up the multiple layers that produce the largest, most destructive stones. That is not a coincidence. The same storm most likely to produce a strong tornado is very often the same storm most likely to produce baseball-sized hail, which is exactly why a single supercell tracking through a populated area can leave behind damage from multiple hazards along the same path. Then there is wind. Damaging straight-line winds, sometimes organized into a long-lived line of storms called a derecho, can produce gusts well over 70 miles an hour across areas hundreds of miles wide. And they often get less attention than tornadoes precisely because they do not have the same visual drama. But the damage footprint from a well-organized wind event can actually exceed that of a tornado, because instead of a narrow path of destruction, a few hundred yards wide, you get a swath of downed trees, damaged roofs, and power outages stretching across an entire region. Meteorologists have been explicit about this point all year. Flash floods and damaging wind gusts can be just as destructive as tornadoes, and they often impact a much larger area, which is exactly why nobody should treat a lower tornado numbers forecast as a reason to relax. Derechos in particular deserve their own explanation, because the word itself is unfamiliar to a lot of people, even though the phenomenon is not rare. A derecho is a long-lived, fast-moving line of thunderstorms that produces widespread damaging wind along a path at least 250 miles long, with wind damage that is often continuous rather than scattered, meaning entire counties can see significant tree and structural damage rather than isolated pockets of it. What makes a derecho so dangerous from a preparedness standpoint is speed, because the entire line is moving quickly, sometimes 40 or 50 miles an hour. The amount of warning time between the sky darkening and the wind arriving can be shockingly short, and because the damage is spread across such a wide area rather than concentrated in a narrow tornado path, the strain on emergency response and utility restoration afterward tends to be enormous, sometimes leaving over 1 million homes and businesses without power for the better part of a week. And then, of course, there is the tornado threat itself, which remains the hazard most capable of producing concentrated catastrophic destruction and loss of life in a matter of seconds. With the shear profile expected to sharpen as the upper-level disturbance moves through, isolated supercells, the rotating thunderstorms most likely to produce strong tornadoes, are a realistic outcome across parts of the risk area, particularly during the afternoon and evening hours when surface heating maximizes instability. The specific concern meteorologists flag in setups like this one is the potential for what's called a tornado outbreak sequence, where instead of 1 or 2 isolated tornadoes, multiple discrete tornado-producing storms fire along the boundary in relatively close succession, sometimes over several consecutive days, as the same broad pattern repeats itself. One of the most important developments in how this risk gets communicated is worth explaining here, because it directly affects how seriously people should take a forecast that on paper might look modest. The Storm Prediction Center rolled out a system this year called conditional intensity, layered on top of the traditional probability-based outlook maps. Historically, a forecast map might show, say, a 10% chance of a tornado within 25 miles of any point, and that number alone tells you almost nothing about how bad that tornado could be if it actually happens. Conditional intensity fixes that blind spot. It runs on a scale from 0 to 3, where 0 means normal range storm activity that won't even show up highlighted on the map, and a rating of 3 signals the potential for a violent EF4 strength tornado if a tornado does occur in that area, even if the raw probability of any tornado happening is written as something as low as 2%. In practical terms, this means forecasters can now flag, if this fires, it could be extremely dangerous, even in situations where the overall coverage of storms is expected to be limited, and that is a meaningful upgrade for anyone trying to understand not just whether severe weather is coming, but how bad it could be if it does. Geographically, the corridor drawing the most attention runs from the central and southern plains northeastward through the mid-Mississippi Valley and into the western Ohio Valley, a stretch of the country meteorologists sometimes only half-jokingly call the beaten path, because it has absorbed a disproportionate share of this year's severe weather events already. Cities sitting inside or near that corridor, places like Wichita, Oklahoma City, Kansas City, Omaha, Des Moines, and stretching east toward Chicago and the southern Great Lakes, have already seen repeated rounds of severe storms this year. And this week's setup threatens to add another chapter to that pattern. Areas farther east, across the western Ohio Valley and into parts of the Appalachians, are also within reach as the system evolves and pushes eastward over the following days, meaning this is not a one-region, one-day story. It is a multi-day, multi-region threat that shifts as the parent system moves. Here's how the pattern is expected to evolve as the week progresses. Early on, the atmosphere begins destabilizing as daytime heating combines with the deepening moisture returned from the Gulf, and the first rounds of thunderstorms fire along and ahead of the dryline in the afternoon and evening hours, favoring the southern and central plains. As the parent cold front continues advancing and the upper-level disturbance swings through, the focus shifts northeastward, with the potential for the most organized and dangerous storms, the discrete supercells capable of large hail and strong tornadoes, riding along the boundary through the middle portion of the week. By the latter half of the week, as the front finally begins to catch up with the moisture ahead of it, the individual supercells tend to consolidate into broader lines of storms, and the dominant threat gradually shifts from isolated tornado potential toward widespread damaging wind and torrential flooding rainfall, especially in any spot where storms repeatedly move over the same communities. That transition matters because it means the character of the danger actually changes over the course of the event. The early days carry the sharpest, most concentrated tornado and large hail risk, while the closing days carry a broader, slower-moving flood and wind threat that can affect an even larger population, even as the headline tornado risk eases. Breaking that timeline down further helps explain why forecasters keep describing this as a multi-day event, rather than a single afternoon to watch and then forget about. On the opening day, the atmosphere is still recovering moisture and rebuilding instability after the previous week's activity. So while isolated, strong to severe storms are possible along the dryline, the coverage is expected to stay relatively limited, mainly across the southern and central plains, during the late afternoon and evening. The following day is when the setup meaningfully sharpens, as the upper-level disturbance approaches and wind shear increases across the same corridor already primed with instability, raising the odds of discrete supercells capable of large hail, damaging wind, and a strong tornado or two, especially where the dryline and the front begin to interact directly. The middle of the week tends to be the most volatile stretch in setups shaped like this one, because that is typically when the front, the disturbance, and the richest moisture are all positioned closest to each other at the same time, and it is also the stretch most likely to feature the nocturnal risk described later, as daytime storms that form early sometimes persist and intensify well into the evening hours as they interact with a low-level jet that strengthens after sunset. By the back half of the week, as the front finally pushes through and begins to outrun the available moisture, the individual rotating supercells increasingly give way to broken and then solid lines of storms, shifting the dominant hazard toward damaging straight-line wind gusts and, wherever storms repeat over the same ground, dangerous flash flooding, even as the sharpest tornado threat gradually relaxes behind the front. It's worth pausing on why flash flooding deserves to be taken exactly as seriously as the more visually dramatic hazards here, because it is consistently one of the most underestimated killers in severe weather events like this one. When repeated rounds of thunderstorms train over the same corridor, meaning storm after storm tracks over nearly identical ground because of how the steering winds align, rainfall totals can climb far higher than a single storm's output would suggest, sometimes exceeding what an area would normally see in an entire month within the span of a few hours. Saturated ground from earlier storms this season means some of the soil across the risk corridor has little remaining capacity to absorb additional rain, so runoff happens faster and rises higher than it would in a drier year. The excessive rainfall risk already being flagged across parts of the upper Midwest heading into this stretch is a preview of exactly that dynamic. And it is worth remembering that a majority of flood deaths in this country happen in vehicles, when people underestimate how little moving water it actually takes to sweep a car off a roadway. Now here's the piece of this story that genuinely deserves the word terrifying, and it has nothing to do with wind speed or hail size. It has to do with timing. A significant share of the most dangerous storms and setups like this one tend to reach peak intensity not in the middle of the afternoon when everyone is awake, alert, and watching the sky, but in the evening and overnight hours, when instability built up during the day finally releases against a backdrop of a darkening or fully dark sky. Nocturnal tornadoes are disproportionately deadly for a simple, well-documented reason: people are asleep. Warning sirens outside cannot be heard indoors over air conditioning and closed windows. Visual confirmation, the thing that so often prompts people to take a warning seriously, is impossible in total darkness. Research into fatal tornado events consistently finds that nighttime tornadoes carry a meaningfully higher fatality rate than tornadoes that strike during daylight hours, even when wind speed and path length are comparable, purely because of the compressed reaction time and the loss of visual cues. If any part of this setup's most active window lines up with overnight hours in a densely populated corridor, and current timing suggests at least some of it will, that is the single detail in this entire forecast that deserves the most respect. It also helps to put this setup in the context of what outbreaks like this have actually done before, because the numbers are not abstract. Multi-day severe weather sequences across the plains and Midwest earlier this year put more than 200 million people at some level of risk across a single stretch of days, with all modes of severe weather, meaning damaging wind gusts, tornadoes, large hail, and flash flooding, all possible on the same days across the same broad region, from the Rockies to the Appalachians. Historical outbreak sequences in this same general corridor and season have produced dozens of confirmed tornadoes, hail exceeding 5 inches in diameter, wind gusts over 150 miles an hour in the most extreme documented cells, more than 1 million homes and businesses losing power, and billions of dollars in damage, all within a single multi-day window. None of that means this week's event will necessarily reach that scale. Every outbreak is different, and small shifts in the exact placement of the front, the strength of the shear, or the timing of the upper level disturbance can be the difference between a moderate, severe weather day and a historic one. But the ingredients being discussed here are the same category of ingredients that have produced those historic outbreaks before, and that is precisely why meteorologists are not treating this as routine. Earlier this same year, a different multi-day sequence over the plains and the lower Great Lakes produced a localized outbreak that included an EF3 tornado tearing through a river valley and a state record hailstone more than 6 inches in diameter, a single stone larger than a softball, capable of caving in a roof or shattering a windshield on impact. That event happened in a region that had already logged nearly triple its typical number of severe weather days for the same stretch of the calendar, a pattern of repeated activity in the same corridor that meteorologists have specifically pointed to as a hallmark of this particular season. The lesson from that event, and from outbreak sequences going back decades, is consistent. It is very rarely the storm that gets the most advance hype that ends up causing the worst damage, and very often the storm that forms an hour later than expected, or 15 miles farther east than the model suggested, that ends up being the one people remember for years afterward. That unpredictability at the level of an individual storm cell is exactly why the broader outlook, the multi-day, region-wide pattern rather than any single storm, is the thing worth paying attention to right now, days before any of these individual cells has even formed. There is also a slower building piece of the broader picture worth understanding, because it explains why this kind of setup keeps recurring this particular season. Long-range outlooks issued earlier this year projected somewhere between roughly 1,000 and 1,250 tornadoes nationally, close to but slightly below the historical average of around 1,225, a modest decrease compared to the especially active year before it. But forecasters were explicit that a lower seasonal count does not translate into a safer season for any individual community, because the entire risk calculus does not depend on the total number of tornadoes nationwide. It depends on whether the one storm capable of producing a violent, long-track tornado happens to track directly over a populated area. A quieter year on paper can still contain the single most destructive event in a decade for the specific town that ends up in its path. That asymmetry, a small number of extreme events driving the overwhelming majority of damage and loss of life within any given severe weather season, is one of the most consistent patterns in the modern record. And it is the exact reason meteorologists resist the instinct to describe any season or any individual multi-day setup as not that bad, simply because the broader numbers trend lower than a previous year. There is one more layer to this year's pattern that deserves mention, because it changes the character of the threat in a way that pure tornado counts do not capture. With La Nina fading and the broader atmospheric pattern shifting toward a state that favors organized, large-scale storm complexes over isolated single-cell tornado producers, this season has leaned more heavily toward multi-hazard events, meaning individual days where large hail, damaging wind, flash flooding, and tornadoes are all realistic outcomes across the same broad area rather than a single hazard dominating in isolation. That shift matters for preparedness because it means the old habit of treating severe weather season as primarily a tornado story. Watch the sky, listen for the siren, get in the closet, undersells the other hazards that, cumulatively, cause a comparable amount of damage and a meaningful share of the fatalities in a typical season. A community that prepares only for a tornado and gets hit instead by a derecho or a flash flood or baseball-sized hail is still unprepared in every way that matters, which is exactly why this week's setup is worth treating as a full-spectrum severe weather threat, rather than narrowing the concern down to the single hazard that tends to generate the most dramatic headlines. So what should people across the risk corridor actually be doing with this information, beyond simply watching the sky? The most consistently effective piece of advice from meteorologists and emergency managers is remarkably unglamorous. Know your warning source before the storm arrives, not during it. A weather radio or a phone with emergency alerts enabled will wake you up in the middle of the night in a way that a siren outside your window, muffled by walls, weather, and sleep, often will not. Identify the safest room in your home now, ideally an interior room on the lowest floor, away from windows, and think through that plan while the sky is calm rather than trying to make the decision in the 60 or 90 seconds a warning actually gives you. For anyone who spends time in a mobile home or vehicle during severe weather season, know in advance where the nearest sturdy shelter actually is, because neither a mobile home nor a car provides meaningful protection against a tornado's core winds, and waiting until the moment a warning is issued to figure that out costs precious minutes you will not get back. And for the flooding side of this threat specifically, the guidance is just as simple and just as often ignored. If you come across a flooded roadway, do not drive into it. It takes a surprisingly small amount of moving water, far less than most people assume, to lift a vehicle off the pavement entirely, and turning around costs you a few extra minutes, while driving through costs some people their lives every single year. A few more practical details are worth adding, because they tend to get skipped in the general advice and end up mattering the most once storms actually arrive. If large hail is in the forecast for your area, moving vehicles into a garage ahead of time, rather than scrambling once the storm is already visible, is the difference between a minor inconvenience and a totaled windshield or a dented roof that costs thousands of dollars to repair. If you have livestock or animals that live outdoors, giving them access to solid shelter before storms arrive matters just as much for them as it does for people, since large hail and severe wind are just as capable of injuring or killing animals caught in open pasture. For anyone in the path of a potential derecho-style wind event, treat it the same way you would treat a tornado warning, rather than assuming that because it isn't a tornado, it isn't worth taking shelter for. Stay away from windows, get to an interior room, and understand that a falling tree or a section of roof torn loose by a 100-mile-an-hour straight-line gust can be just as lethal as a weak tornado. And because power outages are one of the most common and longest-lasting consequences of an event like this, having a charged phone, a flashlight, and a way to get emergency alerts that does not depend on the power grid staying up is worth setting up today, rather than during the storm itself, when it is far too late to start looking for batteries in the dark. If you are anywhere inside this corridor over the coming days, from the southern plains up through the Midwest and into the Ohio Valley, keeping half an eye on the official outlooks over the next few days is genuinely worth the 2 minutes it takes, because these setups can and do shift in placement and intensity right up until the day storms actually fire. And if you're watching this from somewhere outside the immediate risk area, sharing this with anyone you know who lives inside that corridor, a family member, a friend, anyone heading through the region for work or travel this week, is exactly the kind of small thing that actually helps someone take a warning seriously a few days from now instead of being caught off guard. If you've lived through a severe weather outbreak before, in this region or anywhere else, the specific details of what you experienced, what the warning lead time actually felt like, what you wish you had known beforehand, are worth putting in the comments, because that kind of first-hand account tends to help other people prepare in a way that a generic list of safety tips never quite manages to. Here is the honest summary of where this stands right now. The ingredients for a genuinely dangerous multi-day severe weather sequence are coming together across the central United States. A strengthening cold front, a sharpening dryline, deep Gulf moisture, instability climbing into a range capable of supporting violent updrafts, and increasing wind shear layered on top of all of it. The threat spans the full range of severe weather hazards, tornadoes capable of the most extreme ratings on the conditional intensity scale, hail large enough to cause structural damage, wind gusts capable of producing derecho scale destruction, and flash flooding driven by repeated rounds of storms training over already saturated ground. The corridor most exposed runs from the southern and central plains through the mid-Mississippi Valley and into the western Ohio Valley, shifting east and evolving in character as the week progresses, with a real and specific risk that some of the most dangerous storms arrive after dark, when the margin for error shrinks the most. None of this is a guarantee of a historic outbreak. Forecasts at this range still carry real uncertainty, and the exact placement, timing, and intensity of individual storms will keep sharpening as the days get closer. But the pattern itself, the specific combination of ingredients converging over the specific stretch of geography and the specific window of time, is the same pattern that has produced some of the most destructive severe weather events this country has on record. That is the part of this story that is genuinely worth paying attention to, not because every setup like this becomes a catastrophe, but because the ones that do almost always looked exactly like this a few days out.